I mean, what excitement. All right, in reality, if you would have been in the course last year and we were using the previous version of this curriculum, we would have started off chapter 1 with factoring. Ooh. And it really hops right into factoring and away you go. When they revised the course, they put factoring way back in chapter 5, which is probably a good thing. So in Algebra 1, we would have done factoring chapter 9, I think it was, chapter 9. So toward the end of Algebra 1, beginning of fourth quarter, end of third quarter, somewhere in there, we dealt with factoring. In reality, factoring is the way you solve anything quadratic and above. All right, quadratic and above. Something where the variable's squared and above. So you've got a squared variable, you've got a cubed variable, etc. Factoring is the key there to solving. And so if we're going to be able to solve quadratics and above, and we need to, then we've got to be able to factor. And so you got to try to refresh your memories. Those of you that are new, I hope you've done factoring in your previous algebra course. You should have. If you didn't, my advice is go on HCS Math class, look up Algebra 1 factoring videos and look at those videos because you're going to have to go back to the basics. And I don't have time to reteach everything in minute detail, although I'll refresh your memory. So we've done all this before, but now you got to remember. All right, so how did it all start out? Factoring out common factors is using the distributive property in reverse. And this is how we start. We got to learn and remember how to factor out common factors. It is the first thing, and honestly, I think the easiest thing. All right, but just some context, right? Distributive property. I'm going to use my color here. This is A times B, right? Plus A times C. And that's the distributive property. And we know that. We know the distributive property. Not a big deal. Distribute the multiplication. And we just did that really last night or the night before or way back on Tuesday when you worked in class, right? We distribute it and we've been distributing. So what is factoring, at least in this first aspect? And the first thing we're thinking about right now is factoring out common factors. Hopefully you can clearly see that common A, and all you're simply going to do is factor it out. If you take the A out of the statement, what's left? The B plus the C. And what have we done? We've effectively done the distributive property in reverse, right? We've unmultiplied, is what we just did. It's unmultiplication. So instead of going from this, ending up in that, we start with this and we unmultiply to that, right? Factoring out common factors first. It's the beginning. It's something you have to look at every single situation in factoring. And as some of you will probably remember, you didn't always remember to factor out common factors first. And why didn't you always remember to factor out common factors first? Because not every problem has common factors. So I'll try to refresh your memory again when we get into those kinds of situations. So we need to start out first off with common factors. So check your answers by using distributive property to see if you get the original. Hey, when you're factoring, you can always multiply it back out and see if it equals the original. You should always know if your factoring is correct if you have time to go back and check. Again, when would you check? After you complete a quiz, after you complete a test, after you work through an SAT, ACT section and you have time if that happens. All right, how do you do it? Look for factors that are common to every term. And that's the key there. The factors have to be common to every term and factor them out as a multiplier of what's left. Factor them out as a multiplier. Right? When we did the distributive property in reverse, if you look up at the top, right, isn't that A a multiplier of what's left? Right, so the A came out, we put a parentheses, and what was left was the B plus the C, and the A is a multiplier of the B plus C. So when you factor out common factors, what comes out is a multiplier of everything that's left. All right, so let's do some examples here Got some color in the beginning, hopefully to help this to make sense, and then we'll roll from there. So pretty simplistic. Hopefully you see that common 5. We're able to factor that common 5 out. Use a parentheses and just write what's left. And hopefully it's obvious to you that what's left is an x plus y. Again, if you were to distribute and multiply everything back out, you would end up right back at the original 5x plus 5y. Okay, so I'm trying to build your remembrance here and try to remember certain situations. So hopefully in B you look at that and you see a common 7, and when you factor that out, what would you have left? What would you write? 7, go ahead and write it. If you get it wrong, you just cross it out and write the correct thing. So what do you get with this one? So you end up with 7 times the quantity and minus 1, right? Don't forget the 1 there. You have to treat that 7 as if it's a 7 times a 1, because you need that place. Remember, if we multiply back out, we got to end up with 7n minus 7. And if you don't include that minus 1, you're not going to end up back there. All right, hopefully you remember that. If not, hopefully we just refreshed your memory and you're good to go. All right, let's do a few more. Lost my shade. All right, so if you look at C, all right, now you don't necessarily see anything that's common. I don't do this, and Algebra 2, hopefully you're not going to be to this point. Hopefully you look at that and you see in C there's a common what? Right, hopefully you see the common 3. For those of you that don't see it, a 6 is a 2 times 3, and an 18 is a 3 times 6, and now hopefully you see the common 3. So again, those of you that aren't adept at factoring, maybe you don't see that, and you'll have to go through factoring the numbers to see what's common. I wouldn't write that as work. I would simply write the next step, and that's fine. So what's left in the front, a 2a squared. What's left in the middle, a positive a. And what's left in the back, a negative 6. And again, if you were to multiply all that out, you'd get right back to the original. So though it didn't look like there was anything common, the factors of the numbers left a common 3. So in D, don't forget the variables, because variables can be common as well. So in C, it was a common number. In D, it's a common variable. And hopefully you're going to say that I can factor out a y, because the first term has a y cubed, y times y times y. But the second only has a y squared, y times y. But the third only has a y. So what's common to all three? Just a y. And hopefully you know what's left. Somebody give me, what do we want? Y times what? What's left? Okay, so 5y squared plus 3y minus 17, right? Again, we took out a common y. Those of you that don't see what went on, again, this is a y times y squared. This is a y times y. And now you can see we took that y out, and that y out, and that y out, the common y from all three terms, and we end up where we are. Again, let me say it again one more time. If you don't know how to factor, I'm just telling you, if you don't know how to factor, you have got to either go to HCS math class and watch the Algebra 1 videos on factoring, or go somewhere else, or get a tutor and ask that tutor to teach you how to factor, because everything from here on out is factoring. Almost everything. So you got to know how to factor. So if you don't, you got to go back and you got to fill in that gap of what's missing there. Okay, so go ahead and do E, right? Now we got a couple things that you can factor out. So you got numbers you can get out, and you got variables you can get out. So just factoring out the common factor. Okay, so hopefully on this one, what do we end up with? A 5ab minus 3c. 5ab minus 3c. Okay, I don't have a lot of time, but I just want to pause for one quick second. I want to show you something. Don't write this, just watch and look. Let me go all the way up here. All right, so let me show you what's kind of going on here. This would be the exact same thing then if you took this and if you multiply this. So we got a 2a out. What if we were to take this and multiply this by a 2a over 2a? It's a form of 1, right? We're not changing the value. We're just changing the form. And instead of 2a times 2a, what if I said 2a times 1 over 2a? Isn't that a 2a over 2a? It is. And what if I distributed this 1 over 2a? Wouldn't that, in effect, put a 2a underneath each of these? And it would. So where are we at? I got a 2a out front. What happens when I divide 2 into 5? I get, or 2 into 10, I get 5. A into a squared, I get a, and then the b. When I divide 2 into 6, I get 3, and a into a, and that's a 1. And lo and behold, we end up with 2a times the quantity 5ab minus 3c. I mean, that's technically what's really going on, but it's so much simpler if you just find the common terms and take them out. We'll use that concept maybe one time down the road in a certain situation. I'll try to refresh your memory with it. Okay, f is abstract in that the common thing is a quantity. This parentheses x plus 4 is one thing, right? If the x is a 6, that parentheses is a 10, right? It's one thing. And so it is common, though, to both terms. And can we then not factor it out? Whoops, I just changed color. Can't we just factor it out like we just factored out those common variables or numbers? So I took it out front because it's common to both. And hopefully what you would agree is left is a 3n minus 5. So I factored out a common binomial. Again, that's abstract, but that is key. Questions on that? Questions? Factoring out common factors. It's the beginning of all factoring. All right, but again, we would have spent one whole day on that in Algebra 1, and you would have done homework problems over those concepts. But that was Algebra 1. We've already learned this. So now we got to get to the next part of factoring. All right, and that's factoring trinomials. All right, so let me try to refresh your memory. So anybody remember the method that we use for factoring trinomials? Luke? Trial and error. So that's what we've got to refresh our memory on. And if you remember, the key is all about the middle term. The middle term is the key to factoring by trial and error. Because the middle term of any trinomial is a product, the multiplication of the outer terms, right? Those are the green ones. Those are the outers. And the inner terms, and that's the negative 5 and the x, right? So it's the product or the sum of the multiplication, the products of the outer terms and the inner terms. Okay, so right now I'm multiplying. I'm not factoring because remember, factoring is unmultiplying. So I want to multiply it first and then show you the factoring of it. Okay, so hang in there. So let's just multiply. X times, here, let me do it. If I don't start the same, then you guys will get confused. I don't want to. All right, if we were multiplying this binomial times this binomial, first thing we would do is x times x. And that's going to be this x squared, right? Okay. So the next thing we would do is take this x and distribute it to positive 2 and get a positive 2x, right? The outer terms would be a positive 2x. The next thing we would do is distribute the negative 5. And we would do the negative 5 times the x, right? That's the inner terms, and that's a negative 5x. And the last thing we would do is done already for us. We would take the negative 5 times the positive 2 and get the negative 10, right? That last one's done. What I'm trying to show you is it's all about the middle term. So when you add the outers, product of the outers and product of the inners, you get a negative 3x, right? That middle term. So what is factoring? Factoring a trinomial is take this and turn it back into that. And that's what we're doing, right? We're going to take that trinomial, we're going to turn it back into the original binomials. It's easier than it looks, and hopefully that didn't confuse you. It's all about the middle, and I'll try to keep bringing that up. All right, let's write a few things, then we'll get rolling here. All right, remember, factoring is unmultiplying. Just want something in your notes when you look back, you read that and remember, okay, yeah, factoring is unmultiplying. And the key is making sure that your choice results in the correct middle term. Okay, so think back to your Algebra 1 experience. A few of you, there were a few of you, you didn't pay attention to the middle term. And you routinely got factoring wrong because you didn't pay attention to the middle term. Well, there's lots of possibilities. And if you don't pay attention to the middle term, then there's a good probability you didn't factor it correctly and you're going to get it wrong. You got to pay attention to the middle term. It's all about the middle. All right, so as we already said, this method is called trial and error, which means you have to persevere. You got to try and try until you unlock the key and find the right solution. You get good and you can do it quickly. You're not so good, it's going to take you a longer time. The better you get, the quicker you'll go. All right, but don't forget, in all factoring, you always have to look every time to see if you can factor out common factors first. Always look to see if you can factor out common factors first. And I'll just keep saying FOCFF to try to remind you to always look for common factors. So factor out common factors first. So reminder, does every trinomial have common factors? No. And that's why students forget to always look. Because they'll go along and they'll do 3 problems that they don't have any common factors. And so they get comfortable, they stop looking because none of them had them. And then all of a sudden they have one with common factors. And now they're in trouble. So you always got to look. Every polynomial doesn't have them, but you must look. So be careful. Every polynomial doesn't have them, but you must look. All right, can't get to my extend page. Okay, so here we are back to this trinomial. Let me go through and try to refresh your memory. So what's the first thing when you get a trinomial? You look for common factors. Are there any? No. Next step is always to make 2 parentheses. Next thing you do, number 3, you fill in the front factors. The front factors will always multiply to the front term. This one's pretty simplistic. You either have x squared times 1 or x times x. Whenever there's an x squared term, it's almost always x times x. So we put an x times x in the front, right? Because x times x is x squared. So again, if you want to over here, you can come over and write x times x if you want. Now we got to fill in the back factors. And the back factors always multiply to the last term. But here's the problem. When you look at this negative 10, so I'm right here on the right, right? Underneath number 4. So if you look at number 10, what are the possibilities? Well, you have negative 1 times 10. you have 1 times negative 10, you have negative 2 times 5, and you have 2 times negative 5. You have different sets of possibilities. So how do you know which one is correct? It's all about the middle term. Which one produces the correct middle term, right? And sometimes, and we'll get to this here real shortly, depending upon the front terms, it can matter what place you stick any given term. In other words, not only can it be negative 1 times 10, sometimes it matters if you put the negative 1 in the front and the 10 in the back, or the 10 in the front and the negative 1 in the back. So all those are possibilities, and you got to find the right combination. So it's all about the middle term. So again, you must pick the correct factors that produce, and the middle is a negative 3x, right? And remember, how does it get there? It gets there by multiplying the outer times the outer. These are the outers. And the inner times the inner. Has to add up to a negative 3x. So in my mind, I'm looking at my possibilities and thinking, what's going to get me to a negative 3x? Is a negative 1 and a 10? It's going to get me to, is that going to get me to a negative 3x? Or is it going to be a negative 2 and a positive 5, or a positive 2 and a negative 5? And hopefully you already figured out a positive 2 and a negative 5. Because here's what I'm doing in my brain. I'm saying, okay, an x times a negative 5 is a negative 5x. That means I got to put a positive 2 in the other spot. Positive 2 times x is a positive 2x. So again, when you do the check, the outers on these is a negative 5x, and the inners on these is a positive 2x. And sure enough, that gives me my negative 3x. Therefore, I factored it correctly. It's all about the middle. It's all about the middle. So again, in Algebra 1, we would have done a day or so of these. But we've already done that. It's Algebra 2. But that's what we did. So again, I'll say to you, if you've never factored trinomials by trial and error, you're quite a bit behind the curve, and you're going to have to make up ground. There's just ground you just have to make up. All right, let's go to the next page. Okay, so now you look at something like this. And hopefully you think, hey, first off, I better factor out common factors first. And what do you see? A common what? 3. Now, your notes and your homework should definitely show that 3 factored out. Whenever I don't see this 3 factored out and it magically appears down the road, you know what I usually conclude? Either the student copied the factoring off of somebody else, or they copied it off the internet and didn't bother putting that step in. Because 99.9% of your brains aren't going to handle that 3 in your head and remember all of what's left. Okay? It's just not going to be the case. So what is this? A 4x squared. And this is a positive 11x. And the back is a negative 3, right? That's what we get when we factor out that common 3. So what's the next thing, right? 2 parentheses. Hey, don't forget your 3 out there. It stays a multiplier the whole rest of the way. Right? That 3 stays a multiplier, and now we're working off the trinomial. Well, in this scenario, whoa, beautiful. In this scenario, our front term is a 4x squared. Okay, you might say 2x and 2x. But don't forget, there's another possibility. Again, this would have been a day in Algebra 1. It could also be 4x. It's a lousy looking 4x. It could also be a 4x and an x. And I had you guys write out the possibilities ahead of time so you remember they're there. All right? Because remember, you got to take factors of the front. So again, just to be clear, this 4x squared can be either a 2x times a 2x, or it can be of 4x times an x. We've got a couple possibilities. Now, thankfully, our last term on this one is easy, or at least easier. We've got a negative 3, and that's either going to be a 1 times a negative 3 or a negative 1 times a 3. So thankfully, those possibilities aren't grand. But here's the reality. If we use this second one, right here, a 4x and an x, does it matter where we put the 1 and the 3? It matters, right? It matters because here's what you're always looking for. I think it was green. The outers, right, plus the inners has to get us to 11x. Again, on this one, the outers plus the inners has to get us to 11x. And we got 3 and 1 to play with. Does anybody see the right combination? So that's what you're looking at. You're looking at your outers plus your inners to give you a positive 11x. That's what you're looking at. That's where your brain is looking. You're using a 1 and a negative 3 or a negative 1 and a 3, and you're thinking outers plus inners, which one gives me a positive 11x? Anybody see it yet? Outers plus inners, got 1. Anybody else see it yet? 2. Keep looking. You got to look. You got to think. I can't think for you. Okay? You got to think. Everybody right now has got to be looking at the possibilities. Again, you're multiplying the outers times what you choose and your inners times what you choose and add them up and get a positive 11x. All right, so let me get a full count. How many think you got it at this point? All right, we're getting more. Keep looking. Something works. Keep looking. It's called trial and error, right? You're trying possibilities right now in your head. If you can't do them in your head, you're going to have to write them. Hopefully you're doing them in your head. You know, you got to end up at 11x. You got to know where you're heading. If you don't know where you're heading, you'll never get there. Okay, so hopefully everybody concluded to go to the second one, the 4x and the x. If I put a positive 3 right here, what do I have right now? I have a positive 12x, right, for my outers. And therefore, when the negative 1 goes in here, I get a negative x for my inners, and sure enough, that's the 11x, and that's the factoring of it. 3 times the quantity 4x minus 1 times the quantity x plus 3. Factoring. It's all about the middle. 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 And how are you figuring out the middle? By multiplying the outers plus the inners. Outer times outer plus inner times inner. It's got to equal the middle. Has to equal the middle. Has to equal the middle. Questions? Is your memory getting refreshed? I hope. All right. Let's do another one. Get rid of that. Go higher. Okay, so now we've got a situation like this. I will tell you this. It is wiser to rearrange things. Your brain will factor it better when things are in order. Highest power first, descending order. So your brain starts cycling through the possibilities. Are there any common factors? Yes or no? Okay, so now we're already into 2 parentheses, right? Next thing your brain says is, what are the fronts? And there's only one possibility. The front's going to be 3a times a. The fronts always come from the front. What times what is a 3a squared, a 3a times a? The backs are possibilities of 2. Good, not many, right? Somebody tell me something unique to this one that has to be the case with this positive 2 in the back. Abigail? the middle's a negative, so it's got to be a negative times a negative to equal a positive 2, right? There's the only way. It's the only way we're going to get a negative in there because our middle's negative. So it's got to be a negative times a negative. So you know what? The only possibilities on this one is a negative 1 times a negative 2. It's the only possibility. Now it matters where we put them. And the reason it matters is that front term has a 3 and this front term has a 1. So it matters where the 1 goes and where the 2 goes. And what are you after? You're after a negative 5a in the middle, right? All right, so take a look, see if you can figure out where to stick it. Negative 5a in the middle. So again, I'm looking at my outers. Oh, you know what? Negative 2 there is a negative 6a. Dun, 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 dun. This thing doesn't factor. Bummer. Right? If you stick the negative 1 there, then you're going to have another negative 1a. So let's see if we go the other way. All right, let's go this way. Negative 1, negative 3a. And a 2 there, negative 2a does factor. We had to switch them around. The order matters, right? The order matters. By the way, I see students do this a lot. So let me, and I don't have a lot of time, but let me do this quickly. I see them do this a lot and say, oop, I got negative 6 and I got to get to negative 5, so I'll put a positive 1 here. Can you use positive 1 and negative 2? You can't, because this has to be a positive 2. So again, when I did that, I said, oh, that didn't work. Negative 1 there, that's negative 3. Negative 2 there, 2 more negatives. Sure enough, I get the right middle, and that's the factoring. All right. Here's another whole nother day. A difference of 2 squares. Difference of 2 squares. All right, I'm just going to have to refresh your memory real quickly, because that's life. Look for common factors. There are none. 2 parentheses. Plus sign in the middle of the first and minus in the middle of the last. Take the square root of the first term and put it first. Take the square root of the back term and put it in the back. Now, normally you wouldn't show those square roots. You'll do that in your head. I'm just putting them there to show you what you're thinking. So what do you end up with? X plus y times x minus y. It's a difference of 2 squares. What is that? The front term is a perfect square. There's a minus sign between them. Back term is a perfect square. So here, I know the bell's going to ring. Let me do this one real quickly here if I can. Get rid of this stupid square. Okay, so completely factor these difference 2 squares. I'm going to go really, really fast. Sorry for that, but such is life with time. So watch. This is your thinking. Just hold for a second. Just watch what I'm doing. I see it's a difference of 2 squares. I put a plus in the middle of one, minus in the middle of the other, always. I now say to myself, what's the square root of a squared? And I say it's a. And then I say to myself, what's the square root of 9? And I say that's 3. And I get a plus 3 times a minus 3. And I factor that difference 2 squares. B doesn't look like it, but B, you better first factor out the common 3, right? Don't forget common factors. And now you can finish it. Plus in the middle of one, minus in the middle of the other, square root of the first, square root of the last. It's awesome. We just covered 5 different days in one day. Such is life. Hey, you got to get it on the homework, and I didn't assign a ton. So if you have issues, you better work some odds on your own. You're going to need to, all right? Videos on HCS Math class if you need the help, as will this one be.